Welcome to the Armado syslog dataflow demo. In this demo, I will be demonstrating how we can send, index, and visualize arrow formatted syslog records. This software dataflow starts with Apache Pulsar, which is a powerful all-in-one messaging and streaming platform. Apache Pulsar supports multi-tenancy, geo-replication, horizontal scaling, low latency, high throughput, and much more. We are using Pulsar producers and consumers to send and receive live syslog records in the form of arrow batches. Apache Pulsar allows for us to quickly and securely send thousands of syslog records at a time. In this demo, we will use Pulsar to send syslog messages in arrow format. Apache Arrow is a language-independent columnar memory format used to effectively represent big data. By using a Pulsar producer, we will send arrow batches consisting of up to 3 syslog records at a time to an Elasticsearch consumer. To demo, I am using a static syslog file consisting of 110 records. These syslog records follow RFC 5424 format, which is the current syslog protocol. The format follows the fields shown in these sample logs shown on the screen. Let's take this syslog entry, for example. Here we can find the following fields: the priority, the version, the timestamp, the host, the application name. Here we would have the process ID and message ID, which are null in this case, and then it's followed by the message. All of the syslogs follow this pattern where we can find all of those fields. Now let's start our producer. So here we can see that the producer has started to send arrow batches to our Elasticsearch consumer. And in our case, it sends 37 batches. Now let's go ahead and start our consumer so we can see what has been sent. Okay, so here we see all of our batches in our arrow tables. So on the consumer side, we are able to see that our batches have been received and we have logged our arrow tables to the console, so we are able to view all of our fields for each syslog record. Our fields consist of priority, the text value of the priority, the version, the facility, timestamp, host, application, process ID, message ID, decode errors, and the message. And we are able to see each batch be received all the way up to batch number 37. And our consumer can keep receiving more and more batches for however many syslog entries come in from the producer. Each record from each of our batches are being dumped into an Elasticsearch sink in order to be indexed later on. Elasticsearch is an indexing tool that provides real-time search and analytics for data. Elasticsearch can be used to store and index logs in order to perform fast searches when needed. The Elasticsearch sink sends the records to our Elasticsearch index, which in this case is just called myIndex. Here we can see a snippet of the records sent to the index, which shows each record's fields and associated values. This just gives us a preview of about 10 records at a time, but we can see that our index has been hit a total of 1,370 times. So now we know that there are 1,370 syslog records stored inside our index. Kibana is a visualization tool that is a part of the Elastic Stack. By using Kibana, we are able to visualize, monitor, and explore all of our syslog records that are inside of our Elasticsearch index. Kibana allows you to create dashboards with multiple visualizations in order to filter and observe the data in different forms. Here we are on the Kibana homepage, where it shows the different solutions it can give us for different data. The homepage provides documentation and quick starts for certain tasks. So here you can see we are able to add different types of data to Kibana, and it also tells us how we can visualize and explore those different types of data, as well as manage and administer our Elastic Stack. It gives us some quick tasks of adding sample data to work with, uploading data from a log file, or using our Elasticsearch data. In this case, we want to use our Elasticsearch data, so we were going to connect to your Elasticsearch index. As you can see, I have already connected my index, but in this case, to create an index, you would go ahead and enter the index name and create the pattern. Since I've already added my index, let's go ahead and move to the Discover tab. In the Discover tab, we're able to see all 1,370 of our syslog records. You're able to preview these records as well as click on them to get a table view or a JSON view. So here we're able to see our Elasticsearch ID and the index it belongs to and see that it is a type of doc. We're able to see all our syslog fields as well with their associated values. You can also view it as JSON. A big benefit of Kibana is being able to create dashboards. Dashboards allow us to have multiple visualizations of our data on one screen with different filters and charts in order to get the full picture of our Elasticsearch data and fields. I have already created a demo dashboard, which I am able to navigate to in our Dashboards tab. Here we are able to see many different visualizations that I have created. Our first visualization we can see is just the count, so we know we have 1,370 syslog records. We are also able to see a line chart of a timeline over the last 24 hours. And over the hours, we can see where we sent the most syslogs and where we sent no syslogs or the fewest syslogs. I have also created a vertical bar chart that observes the different priority values in our total syslog count. So here we're able to see that a priority value of 5 was hit the most out of all our syslogs, and there were a few with 6, there were very few with 4, and there were none with 3 or any other values. I also created a data table visualization where I was able to set specific fields equal to specific values. I chose these by random, but you're able to do this with any field and any value. So for my first value, I can see that there are 6 syslogs out of my total syslog count that have a version value of 9. We're also able to see the amount for the priority of 5, as well as the priority text values for warn and notice, and we can see how many times that the host AYRIC2204B was hit, as well as facility 0 was hit. And then the star represents the total records, which is, of course, 1,370. I was also able to create a horizontal bar chart of the unique counts for certain fields. So in this case, I chose the fields of unique count priority, facility, version, and priority text. Unique counts allow us to see how many different values belong to a specific field. So here we're able to see that there are 4 different values in all of our syslog records for the field of priority. We're also able to see that there are 4 different facility values in all of our syslog records. We're also able to see that out of all of our syslog records, there are 13 different versions. And lastly, we're able to see that there are 4 different priority text keywords in our syslog records. I created a pie chart that divides the different hosts into percentages. So you can see there are a total of 3 different hosts, and the host AYRIC2204B accounts for 37.15% of the total syslogs. We can see that the host RCohen2204 accounts for 33.65% of all syslogs. And lastly, we can see that the host Encadeo2204 accounts for 29.2% of all syslogs. In addition, I created a histogram visualization, which shows the timestamp per week for each different application. So you can see that the week starts at October 22nd and goes through November 26th. Within these weeks, we're able to see the count for each different application. So we can see in the week of October 22nd that all the syslogs had the application of kernel. We can see the same for the week of October 29th. For the week of November 26th, we're able to see the count for different applications that were hit. So we see that kernel was hit 841 times. The application snapd desktop was hit 8 times. Systemd was hit 8 times as well. Pulse audio was hit 2 times. And tracker miner was hit 2 times. Lastly, I created a tag cloud visualization board, which is just a quick and easy way to see the highest count of a keyword for one of our fields. So I chose to use the priority text keyword, and the biggest word represents the highest count. So here we were able to see that notice was hit the most out of all our syslog records, with the next one being info, and errors and warn seem to be about the same. So we're quickly able to see that warn wasn't hit too much, and just a priority value of notice was hit the most. So this now concludes our syslog data flow demo, where we were able to see how to take arrow batches of syslog records and send those batches using a pulsar producer. We were also able to see how to index the records using Elasticsearch, and then we were able to see how to visualize the data in several different ways using Kibana dashboards. Thank you.